Okay, so now that we know what to integrate, like we have the region we can integrate, we need to fill in the blanks of what go in here, right? What goes into all these limits over here. Okay, so like I said, I like to sort of build it up bottom up. Start with, in fact, this is actually easier with top down. So I'll show you this. The reason is because it's already given me the Z limits, right? So Z has to be from 1 to this surface. So this is basically right, making Z the subject from here. When you make that a subject, you get the curve. So sorry, you get a surface. What surface is that? It's basically the surface of this cone. Right? So that's the lower bound for Z. Okay. So in fact, we are going to do Z first. So the lower bound is from, as you can see here, right? So the upper bound is this part, and the lower bound is this whole cone part is forming the lower bound of it in terms of Z, right? In terms of the Z direction, the lower bound is the cone. Imagine a cone. That's the lower bound. That surface. We'll worry about Y later. I know we're just doing half of the Y, but imagine you have the full cone, right? Actually, it's slightly easier if you imagine with the other part. Then the actual cone part is the lower bound for Z. The upper bound is 1. Okay, so we have this. That's easy to fill in. Let's put in the integrand first and just copy that. That's not the important part. Okay. Make that different color. Right, so that's just copied down there. And now I need to find Y. Well, again, this is giving me some hints already. Y needs to be larger than 0. So I know the lower bound has to be 0. What's the upper bound of Y? Where do you want it to end? Let's look at, again, cross sections. From here, it looks like if Z equals to a constant, let's say Z equals to 1. So let's think about it, right? So if we Z equals to 1, what is the where? So on this plane, on the plane of Z equals to 1, we want Y to start from here and end here. What is here? What does this mean? Well, this is the line of Y equals 0. And what is this line? I'm allowed to have it as a function of X, right? Because I still have the X at the very outside. I cannot have it as a function of Z, but that's fine. We're already fixing Z to be a constant. Okay, so what is this line? That's a circle, right? There's different ways you can think about it. You can just think of that's a circle. What's the radius? Radius 1, right? So this is the line that's part of x squared plus y squared equals to 1. So y is square root of 1 minus x squared, like that. That's one way to think about it. Technically plus and minus, but you know it's the plus side. Another way is you can just, you know that this line is part of the cone, right? You know that this line over here is part of the cone. So you can look at the cone equation and just set Z equals to 1, right? So you have 1 equals to x squared plus y squared, which tells you y is square root of 1 minus x squared. The positive square root in this case, positive square root of that. That also works, yeah. So you know that this is part of the cone, right? Yeah, so it's part of this surface, and you can just set Z equals to 1 to extract that out. Yeah, or just think of that as a circle. Okay, so this can go from to up to 1 minus x squared, like that. Okay, and finally, what does this go? This is x. Well, x can go from, what are the values of x? We want x to go from minimum value of x is -1, maximum value is +1. So that's where we'll set that at -1 to +1. Okay, right. So that should be the result of all these limits. Obviously, this question specifically is asking you to, well, we sketch the domain of integration, but then try to do this in cylindrical coordinates, not in Cartesian, because that's not a very, very nice function to do in Cartesian, but in principle, it's possible, right? So that's how you set all the limits.